Okay, welcome back grade 10s. This is part 2. In this section we are going to be looking at calculating angles in triangles now. So up until now what we've basically been doing is calculating the sides of the triangle, okay? Bear in mind that when we are calculating those sides we can obviously also use Pythagoras, okay? But now we're going to be looking at calculating angles in triangles, okay? So what if they give us two different sides and we want to know what that angle is going to be? How do we do that? Okay. So we have calculated the length of an unknown side using the angle thus far, but the opposite is possible too. So let's calculate the unknown angles of a triangle if we are given two known sides. To do this, we must use the inverse trig function, okay? These can also be found on your calculator, although they are slightly hidden. On your classic calculator, they are normally yellow. So what we have to do is press that little shift button, it's usually at the top left of your calculator, okay? And then press your function of interest. So you'll press shift sign for the inverse sine function that we state as being sine to the power of -1, sine -1, okay? The same is true for cos and tan. You want to press the shift button and cos, or the shift button and tan. That is what we call the inverse trig function, okay? So we use this mostly to get the angle on its own in one of our equations, okay? So, for example, if we have sine of theta equals half, let's say that we're given a triangle, we know that the opposite is equal to 1, the hypotenuse is equal to 2, then what is the angle, right? So I come up with this equation that looks like this from my SOHCAHTOA. Sine of theta is equal to a half, okay? And now what we do is we actually need to bring this sine over to the side so that we can get this angle theta on its own. That will give us the angle, okay? What happens when we do that is we get theta is equal to sine to the power of -1 of a half. It is the inverse sine, okay? And we type that in our calculator now. So you want to press shift, you want to press sine, so you get the sine -1. In your brackets now, you're going to put a half, okay? And then make sure to close your bracket again, okay? And what we find is that theta is equal to 30 degrees. That is our answer. That is our answer for theta. How big is theta? Okay, again, where will this come from? So I'm going to very quickly on the side here draw a right angle triangle. Let's say that this was my theta that I'm looking for. I know that sine is opposite over hypotenuse. So this is 1 over 2. Okay, that's where my, if I write SOHCAHTOA, all right, sine is opposite divided by the hypotenuse. It's 1 over 2. That's how I got this equation, okay? Then I took that sine over to remove it, okay, and get that theta by itself. I type that in my calculator and I get theta is equal to 30 degrees, okay? Beautiful. Now let's try and apply our knowledge in some examples. So example 5 says, determine the size of the unknown angles, theta, alpha, and beta, and also, just as an extra, the length of the unknown side in the following triangles. Okay, so let's start by figuring out what alpha is for our first question. So I want alpha. Now, I'm going to quickly analyze my triangle. Here's my alpha over here, okay? What information do I have? Well, this would be my opposite. This would be my hypotenuse. And just for reference, this is obviously going to be my adjacent side. Now, I am given the opposite and the hypotenuse. So immediately I need to go and find which trig function is going to be applicable. So I'll write my SOHCAHTOA down. Okay, I'm looking for opposite and hypotenuse. So I see here opposite hypotenuse. So is going to be my function of choice, which is sine. So I write sine of alpha. Remember, I'm just stating my definition here, is my opposite, which is 4 over my hypotenuse, which is 5. So I've got sine of alpha equals 4 over 5. Okay, I am interested in alpha. How do I find out the value of that angle? Well, I need to bring this sine over to this side. Okay, so I find that alpha is equal to sine -1 4 over 5. Okay, that is my inverse trig function. What does sine -1 even mean? Or where does it come from? I just want to show you something very, very quickly, so just bear with me. If I have xy is, let's say, equal to z, right? Xy equals z. And I bring this x over to this side. What I get is y equals z over x. And anything, when you have x in the denominator, we can, if we know our algebra, bring it up to the numerator, and we'll get y is equal to x to the power of -1 multiplied by z, right? That is the algebra that we covered in the first quarter. That x to the power of -1, I like to think of that as my sine to the power of -1. I've brought my sine over, so it's the inverse sine. Can you see that? So just a little bit of knowledge there for you to chew on, okay? Nonetheless, I am going to go ahead and I'm going to pop this in my calculator now, okay? Sine -1, so I'm going to press shift, then I'm going to press sine, and then in my brackets, I'm going to put 4 over 5, and then I'm going to close my brackets, okay? And what we find is alpha is equal to 53,13 degrees. Just going to round it up to 2 decimal places, okay? So I know what my alpha is now. Alpha is 53,13 degrees. I can now use that. Right, to determine what this angle is over here. For instance, I can actually find out what that angle is over there because I know the interior angles of the triangle equal 180 degrees. So I can figure out that angle if I want. I can also use this to determine my adjacent if I want. Okay? Now, because this is a long decimal string number, I actually prefer to opt for Pythagoras in this situation. Okay? If I want to know what this adjacent side is, right? AB. And the reason I'm saying I'm looking for AB because that's the next question, right? If I'm looking for AB, I'm going to opt to use Pythagoras. Why is that? Okay, because I have a solid number 4 over here. I have a solid number 5 over here. Okay, and by using Pythagoras, I am most likely to come up with a nice solid number. Okay, what us teachers like to do is we like to use solid numbers as often as we can. All right, and you will find that we are often using what we call Pythagorean triples. Okay, Pythagorean triples. That means that all the sides of a triangle are going to be whole numbers. Okay, it's very, very common. Go onto Wikipedia or go onto Google, just type in Pythagorean triples, see what crops up. Okay, you'll see a set of 3 numbers, whole numbers, and as teachers, all right, we like to use that a lot, okay, because it makes our maths beautiful. Nonetheless, let us now go and calculate AB. So AB is my adjacent, my hypotenuse being my longest side. I'm just going to highlight in blue over here, and my opposite is this 4 over here. So Pythagoras says that our longest side, which in this case is AC squared, okay, is going to be equal to the sum of the other 2 sides. So I'm just going to say AB squared plus BC squared. All right, so there's my Pythagorean equation. What am I looking for? I'm looking for AB. So I need to rearrange this equation a little bit, okay? I'm looking for AB. So I am going to go and take this BC over to this side. If it's a plus on the one side, okay, it's going to go through a wormhole. You're going to get the inverse on the other side, okay? We're going to get a negative BC squared on the other side. So what I end up with is AB squared is equal to AC squared. It's always the bigger one minus the smaller one, okay? So it's the biggest one's always your hypotenuse minus your smaller one, whichever one that might be. So minus BC squared, okay? Now, if you know me, again, I'm the kind of person who just likes to write as an equation in terms of my unknown variable I'm trying to solve. That way I can just plug it directly into my calculator and pop out the answer, okay? It's sort of just a one-step process by doing that. So I have AC squared, AC being 5 squared minus BC being 4 squared, okay? 5 squared being 25, 4 squared being 16, 25 minus 16 is 9. The square root of 9 gives me 3. What are my units? Undefined, so I like to just write units. AB is equal to 3 units. Okay, and there you have it. We've solved this unknown side over here. Okay, I hope that's making sense. Notice how we are now starting to use Pythagoras in with trigonometry. We use Pythagoras a lot in grade 10 trigonometry. So if you aren't brushed up and very familiar with Pythagoras, please go and revise it. Let's look at the next question. We are looking at beta as our reference angle over here. From there, what information do I have? I know that FE is my opposite. Okay, my adjacent is equal to 8, and my hypotenuse is equal to 17. Okay? Write SOHCAHTOA down at the top of your page so that you can use it. All right, I want to know what beta is equal to. I only have 2 pieces of information. I have the hypotenuse and I have the adjacent. So I have to find a trig ratio that incorporates both the adjacent and the hypotenuse. All right, so incorporates opposite and hypotenuse, so I can't use that. Chi incorporates my adjacent and my hypotenuse, so I can use that, and I can't use TOA because that's my opposite and my adjacent, and that leaves me with 2 unknown variables. So I am going to use cos. So I'm going to write cos of beta is equal to adjacent being 8 over my hypotenuse being 17. Cos of beta equals the adjacent 8 over the hypotenuse 17. Okay? Now, I need to know what the angle beta is. So I need to take off this cos, bring it over to the other side, and have beta as the subject of my formula. Beta is going to equal to cos negative 1, open bracket, 8 over 17, close bracket. Type that in your calculator by pressing Shift cos, 8 over 17. Okay, and what we get is 61,93 degrees. So now I know what beta is. I know what this angle is. Okay, this angle over here is 61,93 degrees after rounding off, of course. All right, now I need to find EF. EF is my opposite side. I have 2 of the other sides, which are beautiful whole numbers. So why not use them? Yes, you can use beta. You can use the angle beta, the opposite, with either the adjacent or the hypotenuse, and you can use trig to solve the side, okay, as we have done before, but I'm going to opt for Pythagoras in this case. So my hypotenuse being DE squared is equal to the sum of the other 2 sides, that is DF squared plus EF squared. Okay, which one am I interested in? I am interested in EF, so I'm going to take this DF over to the other side, okay, where it's going to become a negative DF. What I find is EF squared equals DE squared minus DF squared. Okay, what I'm doing now is I'm square rooting both sides to remove the square root from EF, and what I get is EF equals the square root of DE squared minus DF squared. Now I can very simply plug in my values, type it in my calculator. Do not forget to square these, please. So I get DE squared, which is my hypotenuse, that is 17 squared, minus DF squared, which is 8 squared. Use your calculator for this. EF pops out to be a perfect 15 units. Very, very nice. Notice how that is a nice, beautiful whole number. That again is what we call a Pythagorean triple. Just so that you know, this is 15. This is a Pythagorean triple. 15, 8, and 17 are three numbers that go beautifully together, okay? We use that a lot in mathematics. Let's do one more, then I'll leave the last one for you. So we want to figure out what theta is. Let me start by analyzing my triangle. Theta is this angle over here. From that angle as my reference, this is my opposite, this is my adjacent, and directly across from my 90-degree angle, I have my hypotenuse, which, by the way, is an unknown side. Which sides do I have information for so that I can find the value of theta? Well, I have my opposite as 5 and my adjacent as 12. So I need to find a function, a trig function, a trig ratio from my SOHCAHTOA, okay, that has both my opposite and my adjacent. Okay, here we have opposite and hypotenuse. That is not going to work. Here we have adjacent and hypotenuse. Nope, hypotenuse is an unknown value, so we can't use cos. Okay, last but not least, I have opposite and adjacent. I have my opposite and my adjacent, and therefore I am going to select tan as my function today. So I'm going to write tan of theta is equal to my opposite, which is 5, over my adjacent, which is 12. Tan of theta equals 5 over 12. Now I need to find my angle. This is not my angle in degrees, okay? To get my angle in degrees, I need to bring my tan over to this side. By doing that, I get my theta on its own. And what I find is I have the inverse tan function, tan negative 1, 5 over 12. Make sure to close your bracket. To type that on your calculator, again, you press Shift, tan. You'll see tan negative 1 with an open bracket. Then you type in 5 over 12. Okay? Close your bracket and press the equal sign. And what we find is 51,34 degrees after rounding up. Don't forget that degree symbol, by the way. Okay, we're working in degrees here. That is the unit that we're working in for our angles. Okay, beautiful. So we found out what our angle was. Okay, you can pop it here in pencil on your question paper so that you have it. Now we are looking for GI. Okay, remember, GI is our unknown side. It is our hypotenuse over here. I've got two of my sides. To find the third side, I use Pythagoras. Okay, so let's do that. Let's set that up. GI being my hypotenuse, so GI squared is equal to GH squared, which is my adjacent, plus HI squared, which is my opposite. Okay, now I just need to square root both sides. By doing so, I managed to get my GI on its own. And then I substitute in my values. Okay, GH being 12 squared, which is 144, plus 5 squared, 144 plus 25. Okay, you can just don't worry about trying to do this in your head. Okay, 144 plus 5 is 169. Square root of 169 is 13. Use your calculator to do that, okay? Use your calculator to do that so that we don't make silly mistakes, okay? I am the kind of person who is hyper prone to, you know, pushing the boundaries of, can I do this without a calculator? Maybe if you write your exam paper without a calculator, I'll give you an extra 10%, but I highly don't recommend that. Do yourself a favor, guys, please. Even if it's something simple, just type this in your calculator. Just pop out the correct answer, okay? Don't mess around. You're making silly mistakes. It is the difference between a 70 and an 80%, okay? There you have it. All right, I'll give you a minute. You can just pause the video if you want. You can give this one a go. We want to calculate the angle alpha, and we also want to calculate the length of KL. Okay, I'm going to give you the answers quickly. So if you haven't attempted yet, just pause the video. Alpha comes out to be 43,60 degrees, and KL comes out to be 29 units. Another Pythagorean triple. Okay. All right. Now we're getting to the good stuff. Nothing that we can't do so far. All right, we're going to be looking at trig problems which involve multiple triangles, okay? So sometimes we encounter problems which involve more than one triangle. These usually require us to use multiple steps, okay? These usually require us to actually start by solving a common side between two triangles, so that we can get into the other triangle and solve some of the problems from that triangle. It is typically always the same thing. Look for the common side. That is normally what we're going to ask you to solve, okay? And then you can go into the other triangle and solve the angle of that triangle, or solve all the sides of that triangle, okay? But we need to get from our first triangle into our second triangle. Let me show you what I mean by that. So example number 6, okay, is asking us to calculate the value of angle D. So this is another way that sometimes we ask you guys, okay? I'm not a huge fan of it, but what this angle D means is that we have A, B, C, D. This is our angle D, the corner of that D over there, okay? So let's analyze what we have very quickly. They've given us this angle A as 25 degrees, okay? From this angle, and I'm just going to write in yellow so that you know that everything that I'm referring to is referring to this angle specifically, this 25 degrees, all right? That makes this our opposite side, that makes this our adjacent side, okay? And that makes this our hypotenuse, relative to that angle. Okay, so I have an angle, I have an adjacent, and remember, what am I trying to do? I'm trying to get to this angle D over here, okay? In order to get to this angle D, I need two pieces of information, okay? If I want to know what this angle is, I need two of the sides. That's what trig is. Give me any two pieces of information, and I'll solve everything about the triangle. What do I have? From this D, I know that this is my adjacent. Thankfully, this is also our opposite, and this is our hypotenuse. Notice how I only have an hypotenuse there. So I need one other piece of information. Well, if I can solve for this opposite using this angle over here, I would have two pieces of information to solve this angle. Can you see that? So often what happens is that we need to solve what we call the common side. This is the common side of the two triangles. This is the side that they share with each other, so that if I solve that side, okay, I have a piece of information for my next triangle. That's basically what I'm saying. So let's see what we can do with this, okay? I'm going to start by, again, writing so, ka, toa, and that is going to help me to determine which trig ratios I can use to solve that common side. Okay, guys. All right, so we need to find a trig function that is going to work for this triangle, okay? So let's see what we've got. we have the angle, we have the adjacent, and we are looking for the opposite. So I'm looking for a trig function that incorporates adjacent and opposite. Let's have a look what we got. So this one, our first one gives us opposite and hypotenuse. We can't use that. Why can't we use that? Because we don't have the hypotenuse. Okay, this one is adjacent and hypotenuse, so we can't use that either. Okay, we can't use that because it also incorporates a hypotenuse. But TOA, on the other hand, incorporates both opposite and adjacent, where opposite is the one of interest and adjacent I have. So I am going to use tan in this situation to solve my unknown side there. So I'll write tan of 25 degrees is equal to opposite, which is BC. This green line over here, BC is my opposite, over my adjacent, which is 12. Okay? Now I need to get BC by itself. The way I do that is I'm just going to very simply multiply both sides by 12. The other way you can think about it is take this 12 over to this side. If it's a division on the right-hand side, it's going to become multiplication on the other side. Okay, so I end up with BC is equal to 12 tan 25 degrees. Okay, and what I'm going to do is I'm very simply going to pop that into my calculator. Okay, and what we find is that BC is equal to 5,59. Now we can round that up so it becomes a 60, but in this case I'm actually going to use my third decimal place over there. What I actually typically like to do is I like to save that long decimal string number into my calculator and use that again. I can show you that in class if you need. But I'm going to save that now, and I know that this BC over here is 5,596 units, okay? Now, don't forget, what are we interested in? We are interested in finding this angle D over here. This angle D. How do I find that angle D? Well, I have my opposite now, and I have my hypotenuse. So I can calculate angle D because I have two pieces of information. Once you have two pieces of information, you can always solve everything about this triangle, okay? So that is my opposite and my hypotenuse. If I write SOHCAHTOA, okay, which one involves my opposite and my hypotenuse? Well, sine does. Sine is equal to the opposite divided by the hypotenuse. So I'm going to write sine of my angle D, okay, sine of angle D is equal to opposite. Now, I'll write it like this so that we can see opposite over hypotenuse. My opposite was 5,596 divided by 10. Okay? Now I need to get this angle D by itself. How do I do that? I'm going to take sine and I'm going to take the inverse of sine. I'm going to take that sine over to the opposite side. What I find is that D is equal to sine -1, the inverse trig function of sine, 5,596 divided by 10. I'm going to pop that into my calculator, and I'm going to find that D is equal to 34,03 degrees. There you have it. Okay, we found the angle D. Remember, that was the initial question. Okay, what is the value of angle D? So this is a very, very common two triangle problem. Just remember that usually the case is that you need to find the common side, okay, the unknown common side of the triangle. So you have to solve it one way, and then you're doing the backwards calculation to find the angle in the second triangle. Okay. Last but not least, I have one more over here for you, and I think it would be a good idea to let you solve this one on your own. They are asking you to determine the lengths of AB, BC, and CD. So there's three unknown sides, as well as the values of the angles alpha, beta, and theta. Okay, So they basically want you to solve everything, right? You want this AB side over here. We're looking for this BC, which is what we call the common side. This is a common side between the two triangles. Okay, we want to find CD. All right, so we want to find those three sides. What we also want to find is the angle theta and the angle beta. Oh, sorry, and the angle alpha, of course. Okay, which angles have they given us to start off with? Well, they've given us this 50 degrees, so we can use, right, trigonometry to solve our unknown sides. We can also solve this side using trigonometry from that 50 degrees, okay? We can obviously solve for alpha. We know that the internal angles of a triangle is equal to 180 degrees. We can use this common side, once we found this value, along with this side to find beta. We can find theta, and we can even use Pythagoras to solve for CD. Okay, I want you to try this one on your own. So pause the video, see if you can do it. I am going to give you all the answers quickly. So attempt it first and then check if you can get these answers. Okay, here we go. All right, so alpha came out to be 40 degrees. Theta came out to be 47,86 degrees. Beta came out to be 42,14 degrees. At the top here, AB came out to be 11,49 units. BC, which is our common side, came out to be 9,64 units. CD came out to be 8,72 units. And that is that. Okay, so check your answers, check if you got all of those correct. Thank you for joining me, it's been amazing. I hope this introduction to trig has enlightened you and empowered you to absolutely crush any upcoming exams that you have, and will serve you well in your finals as well. So you'll always have this video to approach the introduction to trig. Thank you guys.